So hello students, the topic for today is radioactivity. I will be telling you about what is radioactivity and how was it first discovered. It is an introduction topic, and one thing you would be happy to know that it does not have any numericals. So no numericals from this chapter for ICSE. No numericals. I think some of students would be happy by knowing about this thing, but trust me, this is a very interesting chapter. And so let us start with what is the meaning of radioactivity. Now, as we know, that is if we have studied about chemical reactions. So why do atoms, or why do radicals, or why do different molecules enter into chemical reaction? The whole purpose of entering in a chemical reaction is that they want to achieve stability. That is stability of atom. Either by sharing of electrons or by donating of electrons in that way. Now we are not going to study this particular fact, but we are going to study, that is moreover, the stability of an atom. So now you will ask, sir, is atom or is stability of nucleus? I will say nucleus. So stability of nucleus. So is the nucleus unstable? That would be the first question which would be there in your mind. Yes, actually, if you can see, that is most of the elements which are having atomic number greater than 83 are unstable in nature. So what do? If this element is there, suppose if this X element is there whose atomic number is more than 83, now it will try to emit certain radiation. From its nucleus to gain stability. So we can say that what is radioactivity? So radioactivity is nothing but an unstable nucleus tries to become stable by emitting certain radiations, or we can say certain radiation or a certain charge. Now what does this radiation contain, and things of that we will discuss in the further part of the lecture. So understand that is radioactivity is nothing but a nuclear phenomena. So what is the first thing which we know, we should know? That is radioactivity is firstly a nuclear phenomena. That is it happens only in the nucleus. Now if we consider radioactivity, then the very first element which come into anyone's mind is uranium. Now supposingly if I have certain number of uranium atoms, all these are uranium atoms, all are of the same size, atoms of similar element are alike except isotopes. So all these atoms are alike. Now are all these uranium atoms are they emitting radiation? No. That is, we can say that some of these uranium atom would be emitting radiation. This will start emitting radiation. Then after some time this may start, So we can say that radioactivity is a nuclear phenomena. It is also a spontaneous process. That is, it starts emitting radiation on its own, and that too very spontaneously. Third thing, it is a random process. That is, no one can predict which atom is going to start radiating rays, which atom is going to start radiation. So it is a random process. It is a random process. Okay. Now the other thing which we wanted to, which we should know, that is, it is unaffected. It is unaffected by temperature, pressure, or other chemical conditions, That means you cannot say that if the temperature of this uranium atom is, let us say, 100 degrees, so it will start radiating faster. No, radioactivity does not depend upon temperature or the physical condition. Neither it depends upon temperature nor it depends upon the physical condition. Even if uranium is frozen, or even if uranium is there in ice or in like say plus 100 degrees Celsius, then also the radioactivity is independent of these factors. Now what exactly happens in case of a radioactivity? That is, you can see, that is, supposingly an unstable nucleus, as we have discussed earlier, that is, unstable nucleus gets converted into a stable nucleus. Now by radioactivity, by emitting certain particles or certain rays, and it tries to become stable. So that means you can say that is a new nucleus, you can say unstable nucleus which is old, and a stable nucleus which is new is been formed. That is, moreover, you can say a new atom is formed. A new atom is being formed, and we would be discussing this. That is, supposedly the most common example is uranium, and we write this as 238 and 92 and 96. Sorry, 238 and 92. So what happens is, it starts now. This is unstable nucleus. So what will happen? Uranium will emit certain rays, and it will become a stable nucleus of thorium of having atomic mass of 234 and atomic number of 90 and atomic number of 90. And in this process, now you will say, sir, now the atomic mass has reduced from 238 to 234. Now where has this 4 AMU mass, where has it gone? Now let us, for the timing, you assume that a particle is emitted which is having a mass number of 4 and atomic number of 2, and this particle is emitted from the nucleus. So that is, unstable nucleus gets converted to a stable one, and it is always accompanied by emission of energy. Now the last point, that is, we need to understand what are the nature of radiations from a radioactive substance. So we would be discussing about this nature of radiations in the next part. So let me clear all this. So it was, the discovery of radioactivity was an accidental one. It was been discovered by a French scientist whose name was Henri Becquerel. Do you need to remember this name? No. Henri Becquerel, he was a French scientist, and he was studying the radiations which are coming out from uranium. Now he had first discovered that uranium ore is emitting certain radiation from itself. and that is not triggered by any external source. So that was the first thing. Now what he did was, he wanted to see, that is as a true scientist, he wanted to see what is how are these radiations, or these radiations are composed of which things. So he had seen how does this radiation behave when they are being exposed to an electric field, and when they are being exposed to magnetic field, electric field and magnetic field. So we will also study, because this will help us to understand what exactly are the rays or the particles which are coming out from the nucleus, Okay, so that is firstly about the electric field. Now let us see, supposingly if I have two plates, two metal plates. These are two metal plates. Now if I connect these plates to a battery, now what will happen then? Now you will say, sir, this plate, since it will be connected to the positive terminal of the battery, so this will acquire a positive charge. It will acquire a positive charge. Whereas since this plate is connected to the negative end, so this plate will acquire a negative charge. And this is how an electric field is been created. Electric field is been created in the laboratory. Even we can create an electric field, but that is out of the course of this particular lecture. So that is, now what Henry Becquerel did was, Henry Becquerel he had taken a radioactive substance. So this was nothing but a radioactive substance, and he had taken this radioactive substance in a box. This is lead box, and the rays or the radiation which is coming out of this were being the effect of the radiations on an electric field, that is how do they behave in case of electric field, is been applied across it. So it was been studied. Now it was been found that certain radiations was undeflected and it went through, Okay, this was the first observation. Second observation was, that is, there were certain radiations which didn't go straight, but it bent towards the positive plate, and there were certain radiations which, what had happened was, they bent towards the negative plate. They had deflected. Deflected is the right word rather than bent. So can I say that some rays went undeflected, some radiation deflected, I can write over here, deflected towards the positive plate. Some radiation deflected towards negative plate. Now you know that opposite charges attract each other. So the radiations which were being deflected towards the positive plate, can we say that they had negative charge, so they were being deflected towards the positive plate? That is correct. So some radiations which were negative, they were deflected towards the positive plane, and some radiations which were positive, they were deflected towards the negative plate. Okay, so these were some of the inferences which were being drawn. That is, okay, now we know that although the rays are coming, so the rays are nothing but that is certain rays which go straight, certain particles which deflect towards positive side, and certain particles which deflect towards the negative side. Okay, so that is the first thing. Now second thing is about magnetic field. What was the nature of the radiations when it was been exposed to magnetic field? Now he had the same setup, but now instead of a electric field, a magnetic field was present over here. Now instead of drawing plates over here, what I will draw, magnetic field which is going inside the plane of the board. That is a magnetic field, the direction of magnetic field which is going inside the plane of the board. I will draw it as cross. So what is magnetic field? What is the direction of magnetic field? The direction of magnetic field is nothing but the direction in which the unit north pole will move when kept in a magnetic field. Now this is a very raw definition, or this definition you should not use in your exam, but it is very easy to understand. That is, supposingly if I have a unit north pole with me, and if I have a magnetic field, that is a north pole over here and a south pole over here. Now where will this magnet move? Obviously from the north to the south. It will be repelled by the north, it will go to the south. So I can say that the magnetic field is going inside the plane. And more discussion on the magnetic field we would be doing in the chapter of electromagnetic induction. So for the time being, just remember, that is, I will draw a small figure over here, and okay, I will erase it later as well. So if this is north pole and suppose this is the south pole, if this is south and this is north of other magnet, then you have studied about the magnetic field lines, that is, they will pass from the north pole to the south pole. So this is the magnetic field. So the magnetic field which is represented by this cross means going inside the plane of the board, okay. Now he had exposed this radioactive substance to magnetic field, and he had checked, okay, what exactly had happened to this. Okay, he had taken, again, this is uranium which was kept in, again, lead box, because normally even today it is being kept in lead box, because lead is absorbing all the radiations. Lead has been absorbing all the radiations. Okay, now what had happened was same thing as it was being studied earlier, that is, there were some certain rays which went undeflected and which went straight, undeflected and which went straight. There were certain rays which deflected over here like this, and there were certain rays which were deflected over here like this. So I can write some rays undeflected, some radiation deflected towards right, some radiation deflected towards left. And okay, what is the nature of charge and everything we would be studying. And this is, for the time being, you remember that the deflection is being given by Fleming's left hand rule. We will be studying about this Fleming's left hand rule in the chapter of electromagnetic induction, but for the time being, you remember that is the deflection of this ray, or this ray is being given by these radiation is given by Fleming's left hand rule. So now what we have concluded from what Henry Becquerel concluded from this experiment, that is, there are three types of rays. One which do not have any charge, one which had positive charge, and one which had negative charge. When one other which had negative charge. So let me summarize all this for you. That is, you can see that is some were positively charged. You can say that some are consisted of positively charged particles. Some are negatively charged. And some are, you can say, they were not having any charge, and you can say better it would be said that they were a form of electromagnetic waves. They were a form of electromagnetic waves. So, okay, let us study all these three. Okay, in brief. Today we will have only the outline of how these radiations are. So, the positively charged particles were also being said as alpha particles. They were also said as alpha particles. Now, alpha particle is what is alpha particle? As you know, it is having a charge of plus 2 electron. That is, the charge on electron is 1.6 into 10 raised to minus 19 coulomb, and into 2, and that is plus. Okay, what is the mass of this alpha particle? It is plus 4. Mass is always plus, so 4 AMU. So how can we represent an alpha particle? Alpha particle, that is, first the mass, then the charge. This is similar, you can say this is similar to a helium nucleus. This is similar to a helium nucleus. That is, helium atom is having 2 proton, 2 neutron, and it is having 2 electrons. Now supposingly, if these shells, if these electrons are not there, then we get the helium nucleus, and alpha particle is nothing but this helium nucleus. Alpha particle is nothing but this helium nucleus, which is doubly ionized, which we will be studying in the next class. So this is alpha particle. Then what about the negatively charged particle? They were also called as beta particles. They were called as beta particles. Now, what is the charge on beta particles? The charge on beta particle was the charge of an electron. Charge of electron. And what is the mass? Mass is mass of electron. So student, isn't it surprising to know that is from the nucleus, from a heavy nucleus, we say heavy nucleus, from a heavy nucleus, both a helium nucleus and as well as an electron is being emitted. An electron is emitted from the nucleus. Okay, so first time when I heard about this, I knew about this, I was really fascinated about this. That is how a nucleus can emit an electron, which is very much similar to which is beta particle. Okay, so a few properties. Okay, what about the electromagnetic waves? The electromagnetic waves were also called as gamma rays. They are called as gamma rays. Gamma. Okay, so first is alpha particle, which is positively charged, beta particles, which is negatively charged, and gamma rays. There are two particles, alpha and beta, and one rays, which is gamma. And gamma rays are nothing but they are electromagnetic waves. They are electromagnetic waves. Okay, and as we have studied in electromagnetic waves chapter, that is gamma rays are having high frequency. So because of their high frequency, they have high, you remember only this thing for today, that is they have high penetrating power, because their mass is very less, they have a high frequency, and the speed is the speed of light, and they have high penetrating power. The penetrating power of beta particles is relatively less than gamma rays. Power, you can say moderate, and the penetrating power is very less, of alpha particles. The last point, before we break off this session, that is you can say the ionizing power. Now we will consider one thing which is called as ionizing power. What is ionizing power? Ionizing power is the ability, see, supposingly if let us say an atom is there, an atom is having electron in its shells, now supposingly if a alpha particle is being bombarded on this atom, then what will happen? There is a likelihood that is it will dislodge this electron from this atom, and this atom will be positive charge, or you can say the atom would be ionized. So this is nothing but the ionizing power. So alpha particle, okay, if the ionizing power is being considered, then if the ionizing power of gamma radiation is least, ionizing power is least, it does not have the capacity to ionize. Okay, it has the capacity to penetrate, but it does not have the capacity to ionize. And the ionizing power, if the ionizing power of gamma rays is X, then the ionizing power of beta particles, it would be 100 times the ionizing power of gamma rays. And if we consider alpha particle, it is having the highest ionizing power, which is 10,000 times that of gamma rays, Okay, and so there are a few things before I sign off, that is first thing, the radioactive radiations consist of two particles, one is alpha, other is beta, and one electromagnetic rays which is gamma. Okay, now the rays which are deflected towards the positive plate are the beta particles. Those which are being attracted towards the negative plate are nothing but the alpha particle, and these are nothing but gamma rays. So remember the deflection, beta particles, since they are very light, they get deflected very easily, and you can see a sharp turn over here, whereas alpha particle is comparatively very heavy, comparatively heavier than beta particle, so it does not deflect with a sharp turn, but it takes a longer turn. Okay, so this is one important thing which you should know. Now just to sum it up, we can say what is radioactivity. Radioactivity is the spontaneous disintegration of nucleus. Which type of nucleus? Of unstable nucleus, and accompanied by emission of alpha, beta and gamma rays and it has been converted into another atom for many elements such as uranium, radium, thorium, they etc. They are radioactive nature. They are radioactive in nature. So it is a spontaneous process, it is a random process, and it is unaffected by all the temperature, pressure, etc. And a new nucleus has been formed when radioactive happens. A new nucleus has been formed. That is, a substance has been transformed. So before going off, let us have a mention of Madame Curie. That is, she was the first person who was the recipient of 2 Nobel Prizes, one in physics and other in chemistry, and both prizes were given to her because of her contribution in the field of radioactivity. So this is there, and her actually at that time she didn't know the ill effects or the harmful effects of all these radiations, and she had succumbed to after being exposed to her the radioactive radiation, and so much so that is when that is her diary in which she had taken all the notes is still there today, and the diary is also radioactive. So let us respect those scientists which had given their entire life in studying this, and so that we know better and we are in a better position. So with this I will stop here, and in the next class we will study about the different properties of alpha particles, beta particles and gamma rays. Thank you.